Welcome everybody to week 1. Today, we're going to start on a new journey on statistics. We will cover the where, why, and how of data collection. So welcome to chapter 1. Let's get started. You have heard about the word data. What is data? There's so much data everywhere. Today, we are going to look at different things. At the end of this video, you would know the key data collection methods. You would also know the difference between a population and a sample. And also, you'll be able to understand the similarities and differences between different sampling methods. We will also cover how to categorize data by type and level of measurement. All right, the question is, what is data? Now, you can define it as any observations that you collect. And that's one of the things you're going to do this week. This week, in the discussion board, you're going to play around collecting data of the temperature each day for the next 1 week. So data, a collection of, so let me write it down. We can see data as an observation. And we can define it as any observation that have been collected or that you collect. I'll try to write as slow as possible. So any observation that have been collected. So an observation would be the temperature right now. So let's say the temperature right now is about 68 degrees Fahrenheit. That's an observation that we are collecting and we store it. So Monday, I collect this data. Tuesday, I collect the same data at a particular time of the day. Now, that's an observation. So any observation that have been collected. So we collect it. What do we do? Now, what do we do with data? One of the things we do is we collect it. Now, after collecting it, we want to analyze it. So we analyze it. And then we summarize it. So trying to know the characteristics of this data. And we also interpret it. And after doing your interpretations, we make a decision. So based on these interpretations, so we make our decisions based off the interpretation. So we become decision makers. As you can see, for this class, we'll make use of this whiteboard. Now, for each chapter, we'll have different pages that will be turned on. All right. Of course, you're here because you want to learn statistics. So I'll start by asking you the question, what is statistics? How would you define statistics? Think about it. And while you're thinking about it, let's look at what we just did here. We have data. And at the very end, we want to have information. And between our raw data and information, we need statistics to transform our data to meaningful information. So we have our statistical procedures here. Such as we try to see how we can describe the data, or we can make inference of our data about the population, which we'll talk about. So have you now come up with a definition of statistics? Well, if you're still thinking, let's buttress a little bit about data. I'll still keep you waiting. Now let's look at a format of what data is. I talked about the temperature data. Now, and I talked about the fact that data is any observation that you have collected. Now, let's assume that we collect some observation for our business, and we have the following information in our data. And by the way, we always have, let me go to one of my favorite exercise apps that collects data of me almost every single day, you know. And if you're wearing a mobile wristwatch, your data is often collected, like the number of steps. Right now, it's 11:16 a.m. and I have about 2,200 steps. Now let me look at one of the data here. So one of the data that I collect every day is my weight, how active I have been, how many calories I have burned, and so on and so forth. So you can have each individual record their data. So they could have their weight recorded, they could have their BMI recorded, BMI, and so on, their height recorded. So this, now each of these components, weight, BMI, height, these are called variables. So right here I have three variables that I want to collect. Now I can collect from person 1, person 2, person 3, and so on and so forth. So now we have three variables. We can enter their weight. So this could be my Dr. Itauma, and I entered my weight is X, my BMI is Y, and my height is Z. Of course, this will be numerical values. And the same for number 2 could be someone else who would enter their records, A, B, C. Of course, we're referring to numerical values. And for a third person who I don't know, maybe his weight is, or her weight is 120 pounds. The BMI is Z, which could be any number, and the height could be any number X. Just, you have a view of what we're talking about. So this is how the data are generally represented. It looks like a matrix. So we would say we have three records. Or we can say we have three observations. Okay? I hope you're following. I'll try to write as clear as possible. I know I have one of the best handwritings in the world. Okay, so who has now come up with a definition of statistics? What is statistics? And by the way, as I said in the announcement, we will be using a hashtag called StatForum. on Twitter. One of the first questions would be, what is statistics? Feel free to answer. Give your own viewpoints. But I will share with you my definition of statistics as we continue. Now, in statistics, one of the first things we have seen is that we collect data. So we collect. So these are the components of statistics. We collect data. We analyze our data. We summarize our data. We interpret our data. And what do? We draw conclusions. So we draw conclusions from data. So we can say that statistics is the science of collecting, analyzing, summarizing, interpreting, and drawing conclusions from data. Yes, statistics is a science. That could be a definition. All right. Next, let's look at two key terms that we will be talking about in this course. In the beginning of this course, we'll look at descriptive statistics. Descriptive. And here we'll look at procedures and techniques designed to describe data. We will also explore the use of Minitab for statistical analysis. I will guide you on how to use this statistical tool. So at the end of this week, you know how to load a data set to Minitab. You would also know how to find the mean. No, that will be next week. You also know how to explore the data. Well, I'll show you how to to summarize the data so you can find the mean, the median, the mode, the standard deviation, the first quartile, the interquartile, the third quartile. All of these will make sense by the end of next week. All right. But this week, you would have fun exploring. We are starting a new journey. That's what we'll look at in descriptive statistics. And we'll also look at how to describe your data visually by creating plots such as a histogram, such as a bar chart, a pie chart, and so on. Then, towards the second half of this course, or towards the end, we'll be looking at inferential statistics. Inferential statistics. Here, we look at the tools and techniques that help decision makers to draw inferences from a set of data. Our course is divided into descriptive statistics and inferential statistics. Okay. Now, one other key, there's so much keywords and terminologies that we'll talk about in this course. One of the keywords you hear us talking about is population. What's a population? So a population is the complete set of all elements to be studied. The complete set of all elements to be studied. Now, in my doctoral dissertation, I examined minority female students in the United States. That means my population of interest are minority female students in the United States. That's the population, the complete set of all elements to be studied. That's a population. Now, of course, I can go around analyzing the whole population of minority students in the United States. I'll be really crazy. Conducting a census for that would be pretty expensive. Now, for my analysis, what I need is just a sample that would be representative of the whole population. So our next keyword here is a sample. And if you're following me, what you must have heard is that a sample is a subset of a population. Subset of a population. Okay? It's a subset of a population. Now, statistics generally deal with sample. And that's why you're here, to learn statistics, whereby you'll be able to analyze a sample data. Now, this sample data, as we'll talk about, will be randomly drawn from the population. And by being random, it means that the characteristics of our sample could be a good representation of our population. All right? So now you can understand what a population is and a sample is. Now, from a population, we can conduct census to get information from all the population. That's pretty expensive. We don't want to conduct census. But from our sample, it's simply a subset of the population. Okay. So I hope you all are following online and also those who are in the classroom here. Right. Now, let's look at other key terms. In inferential statistics, when we get there, we'll be looking at estimations, how to estimate the average, how to estimate the proportion, and so on of let's say, an example would be for estimation would be, so I said estimation. Estimate the average family income of all families in a city based on the average income of a sample of families in that city. That would be an estimation. And our last chapter will be on hypothesis testing, which is a very interesting chapter and the high point of this class. There, we will look at how to use a sample evidence to test the claim that the average family income exceeds, say, $45,000 per year. So, and we will look at other business examples as well. All right. Let's move on to other key components. Definitions. We talked about the fact that for statistics, we collect data. Now, let's look at some data collection techniques. All right. What are some data collection techniques? Let's see those who have read chapter 1 already. Well, one method would be through experiments. We could conduct an experiment to collect data. Another could be through telephone surveys. Another could be through written questionnaires and surveys. You can write that down. And another could be through direct observations and personal interviews. So we could collect data through interviews and even online surveys. And so on. Well, you can start now to collect data based on something that you're interested in, most of you are on all the social media platforms. You can create a survey. And by the way, there is a great tool on Microsoft, so you can explore how to use Microsoft products for creating surveys as well. And if it's something you're interested in doing, you can let me know during the student huddles when we meet during the student huddles, and we can play around collecting data based on something that you're interested in. Okay, what is an experiment? What is an experiment? An experiment is a process that produces a single outcome whose results cannot be predicted with certainty. Okay? Now, we won't look much about an experiments in this class. So all you just need is the definition. There's different experimental design, of course, and an experimental design is a plan for performing an experiment in which the variable of interest is defined. Now, when we are conducting an experiment, we would have what is called a treatment group and a controlled group. And we may want to look at the relationship between the two. So we might conduct an experiment for COVID-19 to see the effectiveness of the vaccine. And we have a controlled group where we assign participants, and we have a treatment group where we assign other participants, and we may want to compare different different types of vaccines to see if there is any significant difference between the types of vaccines that are available today. That could be an experiment that we could study. Okay, now what about telephone surveys? What other examples do we have? For telephone surveys, so typical applications would be political polls, market research, customers satisfaction studies, healthcare studies, and so on. And if you have other examples, you can share on Microsoft Teams. What issues and challenges might we have? Issues and challenges. What issues and challenges might we have? Now, some issues would be some respondents might not be at home when you call them. It requires trained callers. Surveys should be short because otherwise the respondents would hang up on you, and also this calling the cell phone numbers takes time, and so it's a tedious process. So those are some issues and challenges that we may have when conducting a telephone survey. Now, most telephone surveys has what we call closed-ended questions. Closed-end questions. So questions that require the respondent to select from a short list of defined choices. All right, so enough with all these data collection techniques. This is just presented here so you understand how data is generally collected. And of course, you can conduct data collection through written questionnaires, which I mentioned, and through interviews and so on. And let's look at other examples. Now, in terms of interviews, we have what is called direct observations and personal interviews. And these interviews could be structured or unstructured as well. All right. Okay, so let's move on to something different. Now, in data collection, what issues might we have? What are the data collection issues? Well, one issue that we may have is the data accuracy. Now, when entering data, there's a tendency that we might enter the wrong information or the wrong data. So we need to be careful when entering data. Now, another issue we might have, especially when conducting interviews, is an interviewer bias. And then another issue is non-responsive bias. What that means is that, let's say we are conducting a survey at a particular time of the day between 8 a.m. through 4 p.m. And our target population are those who are actually working during that period of during that time. However, when we put up our survey, let's say online, we get to receive participants most that are not working at that time. But if we were really interested in more participants that are working at that period, then what we would experience is a non-responsive bias. Now we would we have other participants who would have completed the survey. However, we are missing some chunks of the population of interest. So that's a non-responsive bias. Now, other bias could also be selection bias. And in statistics, our goal is to see how we can minimize this bias. We could also have an observer bias. We could also have measurement error. An example of that would be, let's say I have a scale and I'm measuring my weight and I stand on it and I check and say, wow, 250 pounds. Whoa, that's serious. That's a measurement error because I'm not 250 pounds. Now, it could be that the instrument was not set at 0, and that way, based on where it was set, it gave me something that is not correct, you know. So that could be an issue as well. Another issue would be the internal validity. And then also external validity. We can talk about that when we meet on Friday. Well, these are just the different type of issues. So we look at the validity and the reliability of an instrument. So how valid is the instrument? What's the validity of the instrument? If I stand on the instrument today and I'm say my weight is 190 pounds, and then I come tomorrow and I check again, would it still be 190 pounds, and so on and so forth? Still, that's not my weight. I'm just using that as an example. Okay, great. So we've talked about a lot of things. We've talked about what the population is. Now you know what the population is. You also know what a sample is. So a sample is a subset of a population. A population is a set of all objects or individuals of interest, or the measurement obtained from all objects or individuals of interest. That's a population. However, what's a census? I said, and I'll give in a different way, a census is is an enumeration of the entire set of measurements taken from the whole population. Conducting a census is pretty expensive. So it's one of the it's costly, pretty expensive. So we deal with a sample that we can easily capture and then make inference from. Okay, so now that we've talked about this, one way of minimizing bias also is by collecting our data randomly. So let's say in terms of selection bias. So one way of minimizing selection bias is through randomization. So if we take a sample, it must be collected randomly. I'll say collect sample randomly. So otherwise, it's going to have a bias to it. So this is a way of minimizing selection bias by going through a random process. Okay, next, let's look at something different. Types of data. There are generally two types of data. We have a quantitative data and we have qualitative data. Now, quantitative data are basically numerical data. And qualitative data are categorical data. Categorical. Now, numerical data could be discrete or could be continuous. And of course, categorical data could also be broken down into what we'll see in terms of the levels of measurements. So these are the two types of data. Now, let's go back to population versus sample. So in our population, the type of so a characteristics of a population is what? So we have different characteristics of a population. Now, the characteristics of a population is known as a parameter. So a parameter is a characteristic of a population. Let me write that. I am writing on my screen, so it's pretty interesting. So a parameter. Now we could have most parameters are expressed as Greek letters. So take, for example, the population mean will be written in, so the population mean is written as a Greek letter called mu. The population standard deviation, which we'll talk about later on, I'm just saying that for now. The deviation uses the Greek letter sigma. So that's a small sigma. It's different from the sigma that you might have seen in algebra, which is, this is a capital letter sigma, which is denotes sum of. We're also going to use this later on in the class. And the characteristics of a sample is known as the statistic. And we're here to learn statistic. So the characteristics of a sample is a statistic. Now one way you can remember these differences. So for a sample, the mean So we use English letters. We use the Roman letters. Now the mean will be X bar, and the standard deviation, standard deviation is S. Okay. Now, one way to remember this is that see, this is P to P, S to S, population parameter, sample statistic, the characteristics of a population parameter, the characteristics of a sample statistic. And that's where the course in statistics is coming from, because we'll be dealing with all of this, trying to estimate the statistic of whatever problems they were tackling. So what's the average weight? What's the average temperature? What's the average grade of students, and so on? Okay, sounds good, everybody? You following? Sweet. Okay, now, of course, a qualitative data is non-numeric, while quantitative data is numeric. Now, let's look at some example. What are some example of qualitative data? Now, an example could be color. So I love blue, as you can see. Your preference could be red, and so on. What's your favorite color? Now, that's a question that will lead to different categories of colors being selected. Now, another category called that could be gender. And another could be race. Any other example? Your zip code could be an example. All right, let's look at quantitative data. What examples do we have? I've talked about weight, height, temperature. So these are examples of temperature. Time. What's the time? So that this is a numerical data. I said height and weights. Let me just write it down here. So these are examples of quantitative data. Okay, we are going on well. Let's see what's next. So I mentioned that there are two types of quantitative data. We have discrete data and we have continuous data. Now, how would you define discrete data? Now, discrete data are basically data that are countable or finite. Now, an example of discrete data would be, how many pens do I have? Well, quite a lot. 1, 2, 3, 4, 5, 6. That's discrete. So discrete data. Now, continuous data are infinite. So it has infinite number of possibilities. An example of an infinite of a continuous data would be temperature. So the temperature could be, so the temperature between 68 Fahrenheit and 69 Fahrenheit has an infinite number of possibilities. Or let's say if your weight is 190, now between 190 and 191, there are infinite number of possibilities. So it could be 190.1, 190.2, 190.35, and so on and so forth. There are infinite number of possibilities. Okay. All right. So before we are, I think, midway in this class, let's look at the 4 levels of measurements. So I said there are 4 levels of measurements. There are 4 levels of measurements. Okay. Now we have nominal, we have ordinal, we have interval, and we have ratio. Okay, so these are the 4 levels of measurements. Who would like to give a try and define those terms? What's a nominal date measurement? What's an ordinal measurement? What's an interval measurement? And so on. Now, a nominal measurement, so not for nominal, we are looking at categories. So remember we said there are 2 types of data. We have quantitative and qualitative data. Qualitative data are basically nominal and ordinal. So we said this is qual. And quantitative data are interval and ratio. I'll say this is quan. Okay. Now, nominal data are not ordered. So these are not ordered. Now, an example of nominal data would be, say, religion. Example, religion. Now, I could have in my data set for you to enter your religion. And so you enter Christianity, Buddhism, Islam, or none. And now, in order to analyze this data, I could say that Christianity is 1, Islam is 2, Buddhism is 3, and so on. Now, these numbers 1, 2, 3, 4, 5. Having 1 does not mean that 1 is better than 2 or 2 is better than 3. So it means that there are no inherent ranking in this data. So the numbers used are just labels. It doesn't mean that 1 is better than 2 or is better than 3 and so on and so forth. So another example could also be race. So if I give some numerical data, I say 1 is Hispanic, 2 is African Americans, 3 is Latino, 4 is any other race. That also does not signify any form of ranking. It does not mean that one race is better than the other, and so on and so forth. Okay, it's just there are no inherent ranking. So we simply say they are labels. Now, for ordinal, the difference here is that it can be ordered. Now, what is some examples? So the difference here is that there is an inherent ranking for ordinal data. And an example of ordinal data could be, let's say, your favorite. I could ask you to rank your favorite movies that you watched this weekend in terms of the based on 1 to 5. Now, it means that 1 would be better than 2, better than 3, better than 4. So there is that ranking. There is that inherent ranking. So that's really the difference between nominal data, nominal measurements, and ordinal measurements. Okay, so let's look at interval. What's an interval measurement? Interval measurements, the key difference between interval measurement and ratio is that in interval measurement, there is no natural zero. So for interval, it's also ordered. It's ordered. And the differences are meaningful. And there is no natural zero. What does that mean? No natural zero. First, let me say that an example of an interval measurement is temperature. Now think about this. What I mean by no natural zero is that 0 Fahrenheit does not mean that there's no more temperature, that everything, we can't feel anything anymore. It's not, so 0 Fahrenheit, it's still you can feel that, okay, it's cold at that time, but it's not that the temperature doesn't exist. Okay, the temperature still exists. So that's what it means by no natural zero. Now, ratio is just like an interval, but with a natural zero. So, and an example I would use, what is a lot of people are looking for right now, money. Let's talk about money. Well, chase your dreams, don't chase money. Now, for money, if I say I have $0, it means I have nothing. I don't have any money. So that's a natural zero. Okay. Now, if I have $1, okay, I have something. If I have $0, I have no money. So that's really the difference between an interval and a ratio. Great. So now you understand the whole idea of data. So we started by what is data, and we have dissected the data to the different types: quantitative, qualitative, and now to the levels of measurement: nominal, ordinal, interval, and ratio. So keep this in mind, and if these terms are confusing, please let me know. Send me an email, send me a direct message, reach out to me through any online means. Let's kick off the conversation. All right, so that being said, that leads us to something different. Let's look at how to develop a random sample. Let's look at sampling techniques. Some students like me writing. I would explore different ways later on, just copying the text, writing, typing beforehand. But I hope you can all read this. So that's a sampling techniques. So there are different types of sampling techniques. We've talked about different types we've talked about an experiment and so on and so forth. But let's look at sampling techniques. Now, an example of sampling techniques could be one. We have convenience sampling, meaning that I want to get to know something, and rather than going through a random process, I simply just ask people around me. Okay, so that will be considered convenience sampling. Okay, but I think I should add some definitions before that. What does it mean by what's the meaning of the word random? Let's have a definition for that. Now, when we say something is random here, what we are saying is that each member of a population, so we're saying that each member of a population have an equal chance of being selected in the sample. Each member of a population has an equal chance of being selected in the sample. Okay, so each member of a population has an equal chance of being selected in the sample. That's a sample. That's what we mean by random. So when we use the word random, think about that. Now, for the statistical sampling techniques that we'll talk about here, we'll look at four. We'll look at four common sampling techniques. Now, the first one we'll say is we have a simple random. Now, okay, let me start with convenient sampling. Now, convenient sampling has no form of randomization being used, but I'll classify that as one common form of sampling techniques, convenience sampling or sample. So for convenience sampling, we are basically using the result or observation that is easy to get. So this is not random. Okay. Now let's look at techniques that are random. So one would be systematic. So systematic sampling now is a technique in which we could say that it's always very nice to demonstrate it when I have students in class. Now, if I put a population in some order and select every Kate number or Kate member. So take, for example, I put these boxes in some order, 1, 2, 3, 4, 5, 6, and so on and so forth. And now I decide to pick every so this is 1, 2, 3, 4, 5, 6, and I decide to pick every even number or even participants in the study. So what I said is that we put the population. So we put a population, POP for population, in some order. And then select every Kate member. Awesome. So that's systematic sampling. Now, the third common one is known as stratified sampling. How would we define stratified? We can think of the definition from the word strata. Okay, so there's the word strata. So that can help us draw a meaning of the word stratified sampling. And by the way, I would show how to do most of this sampling techniques in Minitab as well. So it's something that we will demonstrate. Now for stratified sampling, what we want to do is break our population into subgroup based on a characteristics. So we break the population into subgroups based on the characteristics. Now, these characteristics could be, say, we break a subgroup into different races, okay? And then we sample each subgroup. So, or I could say we break our population into male and female. So there are two subgroups, and now we can break up. I would like to move from gender, so let's go to race. Now we break it into different race, and then we randomly select from each of the subgroups. So that's known as stratified sampling. Okay. Then we sample each subgroup. All right. So one way of putting it to make it much descriptive is that, so if this is one race, so this is race 1, race 2, race 3, and race 4. So these are individuals I'm putting as points. So all these points together is the whole population. Now the population are now broken down into subgroups. So race 1, race 2, race 3, and race 4. And now out of each of these subgroups, we randomly sample respondents or participants from each of these subgroups. And then our data will consist of this new random sample. So I'll call this A, B, C, and D. So our new data will be we can join A, B, C, and D. So that's stratified sampling. And now the last form of sampling we look at is cluster sampling. Now, cluster sampling is similar to stratified sampling. Now, the key difference here is that in cluster sampling, we're not breaking the main population into groups that have a particular characteristic, but we divide the population into clusters regardless of characteristics. And then we randomly select a certain number of clusters. So what that means is that I have this whole big population, and then what I do from here is I just break this into different subgroups, into different clusters. So I could have this cluster, another cluster, another cluster, another cluster. And with these 4 clusters, for example, or I could have any n number of clusters, I randomly select any cluster of interest. So I randomly select the cluster. So that's cluster sampling. And then we add all the randomly selected clusters together, and now we have our new form of data. Okay, so we are really drawing closer to the end of this chapter. So right now, if we need to do a review, you now have a better understanding of what data is. Now, if I ask you what is the data, you should be able to define what the data is. You know what the population is. You know what a sample is. Remember, population parameter, sample statistic. Okay, you know, different form of data collection. We've also covered the different types of data and the 4 levels of measurements. And one other thing I would just add before we end this video is there are different data types. I know we said we have quantitative and qualitative, but there's also what they call time series data and cross-sectional data. In this class, we'll mostly look at cross-sectional data. Now, time series data is a set of consecutive data values observed at successive points in time. Now, an example of time series data would be the stock price on daily basis for a year. That's an example of a time series data. Now, a cross-sectional data, which is what we will look at mostly in this class, is a set of data values observed at a fixed point in time. Now, an example would be the bank data about the loan of customers. That would be an example of a cross-sectional data. And that's what we would focus on in this class, cross-sectional data. Okay, and we have looked at an example of a cross-sectional data earlier. So I came up with this data of this data that's collected at a point in time from different participants. We collected their weights, the BMI, and their heights. Okay, and now we can determine what we want to analyze, what is our research goals, and so on and so forth. You also understand the different levels of measurements, and you also understand that we have nominal. Let me bring it up here. We have nominal, we have ordinal, and we have interval, and we have ratio. All right, my friends. So with these, we come to the end of today's of chapter 1. In the next video, I would show you how to perform some descriptive analytics in Minitab. All right. See you then.